In this video, I'll explain you a complete end-to-end project where we build face mask detection from model training to deployment on a live server. First, I will explain final working project so you clearly understand the end goal. Then I'll break down the architecture step by step. And finally, we'll start the implementation from scratch. If you want hands-on experience with the computer vision, deployment, and real-world AI system, this video is for you. Now project is live when I just browse any image. Let me select this image here. So start doing the prediction. Now its predicted result is that face mask detected with the 94.50%. And you can also see the graph as well, how much the probability for the mask detection and no mask detection. To understand the architecture of this project, I created into two parts. The first one is a model building pipeline. Second one is a deployment pipeline. In a model building pipeline, first we have to prepare the data where the image and label should be available and we'll start doing the analysis. So after analysis, we have to prepare a data, then we'll send for model architecture. Here I will use the pre-trained model, which is a ResNet50, and with additionally ANN layer will also add it. Then we'll send for model building. And then when the model is completed, we'll do for a model analysis where their loss and accuracy graph will create it. And then we'll save the model. When the model building pipeline will complete, then we'll start the deployment pipeline. So in a deployment pipeline, first we have to load the image. At the same time, we have to also load the model. So we'll pass the image into the model and we'll perform the entire action on a Streamlit, on a local, and then we'll get the prediction. Like here, this image wearing the mask. So that's why the prediction will be the face mask detected. So entire operation will be performed on a local, but we have to deploy on a live server. To make the server deployment, we have to first upload our model on a Hugging Face because the size of the model will be a little bit big. And then we'll create a user interface that will be the Streamlit. And then we'll upload the image that will be passed into the Streamlit. That is a user interface. After that, we'll upload the entire code base with the requirement.txt file as well on a GitHub. And after that, we'll also do the deployment on streamlit.io, which you can also see these images. Let me again show you. So that is the deployment that is deployed on a streamlit.app. So you can easily search it streamlit.io. Let me create a file. Is mask one. Okay, so we have to process a multiple things. So of course we have to create a multiple files here. So let me take all the required libraries. I already store all the required libraries. Let me do the copy paste here directly. Okay, these are the required libraries are required. And let me take the headings here. All required libraries. Okay. And some libraries which is specific for to apply the CNN process, TensorFlow, keras, and uh, like all the layers and early stop, convolution 2D, everything we have to require. So let me also do it. Yeah. So these are the data. You can also just see that this is just a checkpoint there. These are the data where uh, we have the with mask and without mask. When you go to the with mask, you'll find it out the images which is stored with mask, and the items are 3000 to 3725. So it's on you if you want to train on all the data, and if you want to train on the some samples of the data, you can also decide it. But first thing is that if you're working on any kinds of uh, supervised problem statements, you have to create a data in a training and testing manner. So currently I don't have a data which is stored in the training and testing manner. So first I will just split it my data set into training and testing manner. So I already have a ready-made code to apply it to make my entire process, entire data into training and testing folder. So yeah, data set is currently my entire data is a data set and slash data. And yeah, let me just do the copy paste here. So these are the code which will help you to make your entire data in to do different folder, training and testing. So training will be stored the same with mask and without mask, and test will also be stored with mask and without mask. Okay, and these are the source folder. These are the input directory, which is the data, data set in a data, and output directory, which is data. Inside I will also create a one more folder, which is a split. Okay, and on that we'll also create a training and testing, right? So these are the process we will apply it here, and the training ratio I just also just make it here key we will take it 80% as a training, and 20% will make it as a testing data set. So let me run it. This will take time based on your PC configuration. Okay, I think yeah, let me also create one more heading. Second point, split data set into training and testing, train and test folder, not a training, train and test folder. And yes, you have to run it only once, run only one time. Okay. So these are the, and same time you can also just check it. The folder is also started creating. Uh, yeah, going back. So in data, there is also inside a data set, there is a data and a split is also created, which I just created with 80% training data set and test 20% testing data set. When I go into training data set, you can see here without mask is currently creating it here. And yeah, the data set it start creating. So these are the data set. So on that, if you have already own data set, you can also just take it here. Okay. And with mask, so these are the with mask are there. So let them create because this one take time to complete the entire process. Okay, now I completely done train test split created, and this particular location data set and split. And let me just load it my train dir. Train dir is equal to the same location which I have defined it is this one. And and after that train as well. The same time we'll also do it for a test. Okay, perfect. Yeah. So let me also just try to just load it one of the images to see that how exactly it look like. If I have suppose want to load any data set, we have the PLT. I think I already imported PLT. Yeah, PLT dot im read, and whatever images I have. So let me just take it the images first. Uh, so there is one library is called as a globe library. I can also okay I can directly import it here. Import globe. Okay, globe dot globe, and whatever folder you have, you can also just decide it. Globe dot for globe, and let's take it the entire things what is available inside that. Let me just take it test dir. Okay, so inside the test dir there is the uh, these are the entire folder, and after test dir, what are the things are there, let me also store it. So without mask, with mask are there, and inside that, uh, so I can, there is two folders, so I have to just make it two star, and whatever things is there inside that, so I'll just get in the entire images. Okay, I'll get in the entire images because I have the indexes are there. Okay, so let's define the indexes idx, and idx is equal to any kinds of images. You can just make it 76, 78, whatever you can just make like that, and these are the path image. Okay, and yeah, I can directly read it there. Okay, I am read here. These are the array format. Then img is equal to, then plt dot im show with that images, and plt dot show. So these are the images, and you can just directly check it here. Suppose if I'm just passing 78, I'll getting it 78 here. So likewise, okay. So you can just get the images, and plt dot access. Let's keep it off. Okay, and yeah, if you want to see that with mask and without mask, I think I have to go in little bit higher number. Let's go in the training with mask. Any index you can just select it, like 3 if I'm just selected here. So you will get it 3. Okay, it's completely the showing the order wise, not the name wise. Okay, and I think 3000 if I just make it, then bound out of bound 300, 200. Yeah, you can see here. So with mask, without mask, you can just easily find it out. Okay, yeah. So perfect. Now it's time to just perform the operations on there. Let me first create it. The trend ds. Okay, trend ds is equal to df dot keras, dot utils dot image dataset directory, and inside that, let's pass it there. Okay, let's pass it there. My trend dir. Okay, so I'll just try to just create it my entire trend dir with the specific image size, not image path. It's image size. Let's keep it. Everything is 128 cross 128. Okay, so every images have the different sizes. Let's keep it in the same size, and we'll also store it into in batch wise. Let's make it 32 batch wise. It's not much important to create it batch wise. It's important for making the faster processing. Okay, if you're not making it batches, so uh, your GPU and CPU will take more time, and that will not be optimized way. That is the reason we are doing it. So there is a 6000 fold files is available belonging to the two different classes, and the size of 128 cross 128. Okay, with the batch size 32, and the entire data is stored in the tensor format. You can also just take it here, train ds. Okay, so the entire data is available in the format of the tensor. Okay, now it's time to just perform the operations. It's time to do the same thing for test ds as well. Okay. And tf dot keras. I think everything is fine. And I think I should also just write it. Okay, it's efficient for GPU and TPU training. Okay, GPU and GPU and TPU training. And output always be in the tensor format, and yeah, the label will always also be in a tensor format. So perfect, that files are created. Yeah, now it's time to do the pre-processing. What were the steps? Now the step number 4, pre-processing. So when you perform the pre-processing, again, I'll just take the layers from TensorFlow dot keras import layers and models. Okay, so let's make it layers dot rescaling will, I think first I have to import it, then I can see models. Okay, layers dot rescaling, and will convert your entire data into the floating point. One uh, one point we usually we writing like this is the 255, and yeah, normalization layer. Okay, let's perform with the same thing for the dir train ds, not ds dot map, and we'll perform it only for uh, our X and Y is you'll get in the both in train DS, you'll get in both like your image data and as well as the labels. So you have to perform it on only on image data. So I'll just perform it here, the normalization layer only on X, which is the image data, and Y will keep it as it is. Okay, train DS new train test is DS new. Yeah, perfect. It's not double P, it's only one P. Yep. Now it's mapped your entire data. Uh, it's it's converted into the normalized format. Step number 4 was there. Now we have step number 5 to perform the convolution process, or we can say the convolution architecture. Convolution architecture, and we'll use it pre-train model, and we'll freeze it entire layers. Freeze entire layers. Okay, so there is a n number of convolution processes, convolution pre-trained model is available. There is n number of convolution pre-trained model is available. So here we're gonna use it ResNet50, where 50 means 50 layers. Okay, so let me just load it first from TensorFlow, TensorFlow dot keras dot applications dot ResNet50 import ResNet50. Okay, so let's first create the base model. Base model is, of course, it will be the ResNet50 base model is equal to ResNet50, and we'll pass it first is input size, input shape. Input shape will be the same is 128 comma 128 comma 3. Okay, and we'll do it include in there is a parameter is called as include true. Will we make it include true is a false, and we'll also be define it weight, and that will as it is the ImageNet. Okay, so whatever image data that is trained with the 10K data 10K data set, and let me also just check it as net 50 trained with how many data. It's overall a 1 million data set, around 1.2 million data set with the 1000 object categories. Okay, so we'll take it that same image net, and yeah, the base model is ready, and we'll make it trainable parameter as a false because we'll freeze it the entire layer base model dot trainable. If you want to do the fine tuning, so that time you can make it true and do some little bit fine tuning. Fine tuning in the sense if you want to add some custom layer in existing pre-trained model, like ResNet50 have a 50 layers. So the last 5 layers or 6 layers, you can also just impact something. You can also just change something. That time you make it true and just change the layers there. So here I'm not gonna use it the any kinds of custom layers. Uh, so I'm just adding a top of that on entire layers and just adding the top of that here. Okay, let me just create it. The final uh, ANN architecture, fully connected neural network. I'll just apply it here. Uh, we can say, yeah, fully connected uh, ANN, fully connected, fully connected layers. Okay, so let's do it. We'll take the model with the same process. We'll just apply it. Model is equal to, and of course, our model is a sequential format, and model dot add, and we'll add it base model. Okay, so now our convolution process is completed. It's time to just make it the directly uh, add few layers and then run it. So model dot, let me also just do it global average pooling. So sorry, add. Okay, so pooling I'm also applying it here, and then uh, model dot one more layer. Let me just apply it dense, and we'll just add it. So what is the output you want to get it here? Let me just make it 256 and 156 likewise as going down. So 256, and then activation function, it's a hidden layer kind of for a fully connected hidden layer, we can say. So activation function will be activation. Why it's not coming? Okay, activation is equal to, it will be relu, and let's also perform it the model dot add and batch normalization, and then model dot add will make it drop out. Okay, for optimization purpose, and let's also make it one more layer, kind of same thing, one more layer here. Let's make it 156. Okay, and inside that it will again be relu, and the final layer output layer is a model dot add, and dense it will be, and output will be the two only. Okay, output only two, because we have the label is a with mask and without mask. So an activation, uh, that two output I'm expecting that, then it will be softmax. If you are expecting only one output, then the sigmoid you can just use it here, but here I'm expecting the two output. So what is the probability we are getting it for with mask and without mask? Okay, and any issues here? Why it's getting the error? Why it's getting it too? Yeah. Then model dot summary, you can just take it. You're getting the entire architecture here. ResNet50, you can find it out the parameter, and 256, this one we also just adding top of that. So total parameter will just total parameter trainable parameter will be this, and the size is a little bit bigger. Okay, non-trainable parameter, that means we are not gonna train it. That is totally based on this number. Okay, that we are not gonna train it, and the fully connected layers which we created, that we gonna train it. So let's compile and then run. Model dot compile, and we'll pass it optimizer first, and the common one will take it Adam. Okay, and loss function, loss will be sparse categorical cross entropy, because the label are integer. We are expecting the label are integer. If your one hot encoder vectors are there, that time categorical cross entropy, that is enough. But here we are the integer labels, we are getting it, we're expecting the integer labels, so it will be the sparse categorical cross entropy entropy and metrics, that will be accuracy. Okay, so let's compile it. Yeah, these are the compile, and then we'll create history is equal to model dot fit. We'll also just store it in the variable history so that we can also just do some output analysis. Fit, and we'll pass it, will pass train ds new, and validation data will just take it test ds new, and we'll take it epochs. Let's how many times you want to do the back propagation, let's make it 30 times, 30 times, and we'll also just take it the batch size. Okay, batch size. Okay, but there is also the lots of hyperparameter tuning you can just perform it here, but this project is focused on how we can create the end-to-end project. Hyperparameter tuning, of course, you can just also do it here. So let's start it now. At the same time, always open your taskbar. Always open your task manager to check that what is the performance is going while you are running on any kinds of machine learning or deep learning project. Okay, CPU utilization, you can also just check it here. So these are the CPU utilization is going the 12%. And when I start running it, okay, when I start running it, there is a 30 epoch I just applied here. So we will get it, the values. Is it kind of warning? Hope it's a warning. Please use df dot. Okay. That's fine. It's just a warning. I think new libraries are updated, so it's giving the warning to use. They're giving the suggestions to use such kind of libraries instead of the existing one. So now, yeah, this one is started, and you can also see that your graph will also be get hyped. Yeah. Okay. So let them run. It will take time. It will take more than an hour time. So let them run, and when the model is ready, the same time you please also save the model. So of course I cannot track it each and every time, so let them run. So I'll just use it model dot save, and just use it uh, face mask model dot h5. Okay, when this one is completed, the same time I will also run it. After that, it will automatically run. So there is no any. So there is no any model. There is no any model is available currently. Let me also show you. uh, these are the Jupyter notebook file and dataset only. There is no model is available. So let them run. So when the entire process is completed, so you'll also get it the model name, which is the face mask model dot h5, and we'll load and do some model analysis. After model analysis, we can also perform some user testing. So many processes are there to do it. So my laptop don't have a much capacity, so I cannot go with the very higher number, which is 30. Let's make it 15 here. So that's why I just stopped. Okay. And I'll show you how much utilization was going when I was running around 30 batch size. 30 epoch, so it's going around 90% utilization. So that is not good for my laptop, so I'll just stop it here, and let me just make it batch size is a 32, and the epoch will be the 15. That is will be enough to train this model, because our target again is not to just complete this project. Our target is that to how to make it end to end process. Getting the higher level of accuracy is just not main target here, because when you just make it epoch is equal to 30, that is again you're not sure that that is the maximum accuracy you reach it or not. Anyhow, you have to perform the operation of um, hyperparameter tuning. Then you'll find it out what are the best parameter to do it. Okay, so let them run, let them complete the process, and then we'll discuss. Okay, now model is saved. We didn't get a good accuracy here, because you can see the accuracy is around 83% and 84%, but the validation accuracy is very less. So I cannot say that it's a good model, but yeah, our target is to complete to end project. So later you can also do the hyperparameter tuning to get the better accuracy. But let's create the graph and check that what is the final confusion matrix accuracy. We can find it out here, because this is the classification model, classification problem statement. That is the seventh point, I think. Yeah, seventh point, that is model evaluation. Okay. So it's already stored in a history, and we can check the accuracy there. Yeah. So plt dot plot, and we can also just take the label. Okay, and then plt dot show. So that is a training, yeah, train, and at the same time, I can also just take it for testing. That is the validation accuracy. That is nothing but a test, and we can just plt dot legend. Okay, legend. Oh, sorry, spelling is wrong. Legend Okay. Yeah, this one is for the accuracy. We can also just get it a loss as well. So plt dot x label number of epochs and plt dot y label accuracy. Okay. So yeah, these are the model evaluation, and the same time we can also just go with loss as well. Loss and validation loss and accuracy. I can just go with loss. Okay. So yeah, this one is loss, training and testing. You can just get it. Uh, accuracy and loss graph. Okay, let's quickly complete the confusion matrix for this graph. Okay, so all the data is available in the test ds new. Okay, so suppose if I want to see any kinds of one data, like because the images are stored here, let me just simply get it both the values um, for x and y. Let's take it both and the first values will store. So why not just break it directly? Okay, so at least you will get the x values, which is nothing but images, and the images there is a 32 batch size is also mentioned there, so I just want only one, so let's take it one. And yeah, it's a normalized format, but I can see the images at least. Plt dot I am show. Okay, at least I can see the images. Yeah, these are the images. Okay, perfect. Now it's time to just do the like getting the prediction from the from y test ds new data set, and we can apply it there. So let me first do the concatenation of the entire data set. So what I will do, first I'll just take the labels y true. I want to only, okay, I want only labels, not images. So what I'll do, I'll just make um, one for loop. I'll just make it for x comma y in test ds new. I already performed this operation. Yeah, test ds new. I'll just take only y. Okay, I'll just take only y. So you'll get it the entire labels. Okay, you'll get the list of the labels. Let's take it only. Let's take it the concatenation so that you'll get it only the labels here. Np dot concatenation, concatenate. Okay, and based on x is equal to 0 means rows. So you will get it. Yeah, 0 1 0 1 kind of values. So let's store it these things into y true and y true we got it. Now it's time to just get the y prediction. So we can directly just get the model dot predict and we'll pass it the test ds new. Okay, test ds new. And when I just directly get the values, let's see what is the result. We can get it here. Yeah, it's running it because again the model is a little bit heavy here, and based on the data set we have a 32 as a batch size. So based on that we are getting the result accordingly. You can also just check it how many data is it's directly getting the prediction because it's an image prediction. I can also see it here. Yeah, 1511 files, 1511 images are predicting it. Getting is that how much are with mask and without mask. So we're getting the result like this. So I don't want both the values. I want the values which is the higher one. Like these kind of images have with mask, right? One miss with mask and zero miss without mask. So what I can do it here, the np dot uh, argument max. Okay, I'll just store it ypred because at least this process will run it again. One more time it will be run, and then later we'll just make it the confusion matrix. So hope you already imported all the libraries. Let me also check that. Confusion matrix libraries. Yeah, yeah, all the libraries I have. So if you want, you can also just take it one more time to just import. And yeah, CM is equal to confusion matrix. We'll just pass it y true and y pred. Okay, so you'll get it confusion matrix, which is this. So this is your final accuracy. You'll go get it here. Okay, final accuracy. We find it out here. It's your answer is a little bit biased. The answer which I'll just getting it here, little bit biased. It's okay. It's fine. Like a bias that we can understand it. But again, um, uh, our main task is that to complete the entire project. Okay, so yeah, that's fine. And let me also just check the accuracy score and pass the values is how much accuracy we just got it. We got the 50% accuracy, which is really very, very bad accuracy. Okay, this is not a good accuracy here. And if bad accuracy at the same time have very biased output. So if your output is very biased, so when you just pass the any kinds of images, so chances that you're getting one kind of result only. But let's see, let's complete this entire project. So I can also just try to find it out some hyper tuning and change the model. Okay. Uh, yeah, but let's do it this one. Let's complete it first. Classification classification report, and we'll just take it the same thing, y true and y pred. So yeah, so recall value for one, getting the mask that we are getting the good result, but zero, which is really very very bad with the 7% of recall values, which is really very bad. Now we have completed everything. Let's do it the user testing and then we'll go for a deployment. So let me create a new file and at the same time we'll also just check it ki model is available or not. Yes, face mask model.h5 is available. So the file name will be face mask 2. Face mask 2. Okay. First of all, I have to just load it all the models here. If I want to load it, so let me also open the previous file as well because I want all the libraries and then we'll load the model, right? So let me just take all the TensorFlow libraries. That is the important one. Okay. And then we'll define the model is equal to TF dot. I think we are importing the TF as well. I think we don't require the keras and the sequential. Nothing is required because anyhow, we are not training the model here. We are just testing the model that is performing properly or not. So tf dot keras dot model. Okay. So whatever load model. Okay. Load model inside that, whatever the file name is available. So the same file name that is not, okay. Uh, File name is this, rename and directly copy paste. Okay. That is a file name and we have to load it. So loading model, of course, will taking a more time. tf.keras.models.load. I think let's not do it here. Keras.models.load models. Yes. Okay. So now model is loading. It is showing the unnecessary warnings here. If you don't want warnings, so you can just directly stop it here. That's I can directly use it. Uh, Import warnings and warnings don't filter warning. Okay, I think I already used here this one. Okay, so let's load the model and then we required some libraries which is focus on loading the images. So I'll just load some libraries here. So I'll directly do the copy paste here because this is just testing and deployment. The main part of the creating the model that is already done. Okay. Now, I have to create the code for uploading the images. This one will help you to just upload the images. Okay, with dot file upload, and whatever the image you will take it, that will directly accept, and it will be stored in the upload variable. Okay, and that will be displayed directly, right? Let me just run it. It will be showing like a upload. Okay, so upload word is showing it here, displaying is upload. When you click on it, then showing the images, so wherever is available your entire data. So let me also just check it, data set here and split. And let's go with the training data itself, because of course model is not as much strong, so you cannot expect that very good accuracy. So let me go with mask and take some images. Let me first go with without mask. Okay, any images I'll just take it, like this one I'm just taking it here, and I upload the images. So when you just your images are stored in the upload. Okay, so when you just check it upload, so you can see that something will be there, like uploaded some images. Now I want to show that images. So now let me extract it, that information. So let me use this code. Okay, so you can also see the content. Okay, so that means that images is stored here, and I will convert my uh, content into the proper RGB format. So here, with the help of OpenCV CV2, I'll just read the images. So when you just check it, image RGB, so it will be look like, yeah, the completely in matrix format. Let me show that images. So make sure that you should have a PLT. Let me just check that. Yeah, PLT is not available. Let me first import it. Import matplotlib dot py py plot as plt. Okay, so let me just import it, and the simply plt dot I am show. Okay, I am show. So when you just check it, yeah, you can see the images as well. But that's not important to see the images, right? If you don't want access, you can just use it plt dot access off. You can do it, and then plt.show. So here, important is not to display the images. The important is that I want to detect it, the person wearing the mask or not. Right. So I already load the model. Now it's time to just convert in the same format. Okay. So when you go back and check that what format we have used, so yeah, I have used the format, the like image size, which is 128 and 128. So I have to just use it in the same format. Okay, so let me again also convert my image RGB, which is storing the images as a variable. So let me just convert it 128 pixels to 128 pixels. So now it's converted into the image array. And what I have done after that, I have loaded, and then we also apply the normalization layer. So of course, I have to also apply the normalization layer in the next part. Okay, so yeah, normalization layer will apply it on my image array. So image normalized, it will be showing. Okay, layers is not defined. Something I'm just missing it, where I is exactly the layers. I think, yeah. So just define it here, layers. So I'll also just take it. Okay, now let me run it again. Okay, so now data is also normalized. It's time to just expand it into proper NumPy dimensions. Okay, so image input, I'll just take it. Let's expand it properly with the proper weights, which is the which is the one images height, width, and like three channels is there because the RGB images. Okay, so image input will be defined the same format which will be trained on it. So we'll directly pass now it our images in properly in the format. You can also see that dot shape. Okay, one row 128, 128, and three as a channels. So now I'll just use it model dot predict will directly pass it the image. img input. Okay, let's store it in some variable. Ypred, I'll just store it because the prediction. So again, it's doing the prediction from the model. So of course, taking a little bit time. So yeah, 4 seconds is taking. That's completely fine. It can be. So Ypred, I can directly check it. Ypred. So yeah. So this is given the prediction is that the first one is a 0 and the second one is a 1. So that meaning is that the person, those who are wearing the mask, it's a face mask detection is that the first one is wearing the mask, second one is not wearing the mask. Okay, so I'll just make the condition accordingly. I already make the condition. I can directly show you here. Okay, I already make the condition. Yeah. So Ypred, of course, it's a 2D list is there. So 2D array is there. So we'll just take it one values. So if the first values is greater than the second value, first values is greater than second values, then we can directly go with the mask detected and otherwise not mask detected. So current situation, of course, no mask detected. There is no any mask is here. Okay, and at the same time, if you want, you can also show it the images. You can take the same code. You will also find it out this code on a description in this video. I have already given the complete GitHub link, so you can also refer it. Okay, so this is the images. There is no any face mask. The problem of this the entire project is that in this project, so our model is not as much strong. So please do not test with any kinds of testing data. Test with the training data itself. Right, because model is not as much strong here. So what you have to do from your end, you have to just working on hyperparameter tuning so that make your model is more stronger. Okay, so here in this video I've already explained each and everything, the pipeline perspective. So at least you'll get idea how the entire project is working. Okay, let me just take any other images. Like I'm just taking this is a mask one, and then run it. I think this one is, yeah, run it. This is the images. And when you run it again, so what is saying that no mask detection again, because as I said, this is the wrong prediction because our model is not as much strong. It's just a 51% accuracy level. So I have already chooses some images which is giving the proper prediction, because at least your model have a 51 accuracy, right? So some images can be predict properly. Suppose if you're taking this images, I'll also share with you this image on your GitHub page. Okay, with mask and without mask. And when you run it, this is the images. And when you run it here, so it's saying that mask detected with 94% accuracy level. So yeah, we successfully did that user testing. Now it's time to do the deployment. Okay, if you want to do the deployment, you cannot do it the Jupyter notebook, right? Because you know deployment we are doing it at Streamlit, and after that we'll also go on a live. So in that situation, we just required some requirements.txt file. We required a Python file, so we cannot do it in a Jupyter notebook. So I suggest you please uh, open the VS Code or any kinds of. Ideally, you can just choose it. Okay, so let me also open the VS Code here. Yeah, this is my VS Code. I also recommend you please working on VS Code only, because you'll also find it out the Copilot here. If you are not able to connect with the Copilot, this is the video I already made it. You please watch this video. You'll find it out each and everything. I have explained each and everything how we can connect uh, uh, Copilot with a VS Code. Because if you want to create any kinds of code, if you want to do any kinds of setup, so if you have the agent mode, ask mode, so you can easily do it. Because here I want to create this just normal deployment. Deployment connectivity already have a tedious tasks, but writing the code we don't want to spend much time. So in that time, Copilot can easily do it. Please also refer it. Okay, so let's start it here. You have to create one file, which is the let's create the file name is app.py. App.py. Okay, so in this file we'll gonna deploy it this Streamlit, and after that we'll make it live. Okay, so yeah, first thing is that I have to create a proper user interface. Okay, the Streamlit have a very very basic code is there to do it. So, interface. Just import Streamlit as ht, and after that you can just define something whatever you want. I just want to define the set page configuration. Okay, just normal page configuration you can define it, and define the titles. Okay, let me define this few things here. And now, uh, I think we can directly test it. That is properly working or not working. Okay, that's enough. We'll go it one by one in everything, but let's run it. It's properly working or not. So whenever you working on any kinds of applications, so terminal, you can directly open it here. And if you want to create a new environment, you can. So I prefer to always go with new environment. That is the good choice. But the Streamlit deployment is not much important to create a new environment. But if you want to do it, the plus point is that you have a VS Code. You can just have an agent mode. You can directly tell them, I want to create a new environment with some specific version of the Python. You can do it, but let's not make it that way. So let me just check it what version I'm just using it Python. So I'm just using a 3.11.9. In a deployment time, I have to also remember it that what version I've just used it. Okay, the same version I have also used it for the creating the models as well. Okay, so I'll follow the same version in entire code space for creating the models, for testing it, for deployment, everything. Okay, so let me just run it. The Streamlit file, it is already there in the same space, same uh, folder, app.py. So let me just run it. Python, sorry, Streamlit run app.py. So when you just run it, so this normal whatever configuration, whatever title, markdown you have just mentioned there, it will be showing on directly the web page. You can see yeah, face mask detection, upload and images, whatever things I just mentioned there, it can be visible here. So this is small code I just mentioned there, whatever you will write. Important in these things that you have to just import it, and whatever you will mention, it will be shown directly. It's very much easy to deploy any kinds of POC related work. Doesn't matter you're working on a machine learning, deep learning, you can easily deploy it here. Okay, so let's go with one by one. If I want to deploy such things, if we want to test it here, so let me just take it all the required libraries. Okay, these are the required libraries are here. And one more thing, um, so at the end your model should also be coming from some spaces. Like I want that this entire application should be accessible from anyone. So that means I will deploy on a cloud directly, or Streamlit app directly there on a cloud, so that I can just provide the link to anyone, they can access it. So that means the model should also be available. I have to load the model as well. Okay, model should also be available in some space where I can directly fetch it. So we have a multiple spaces are there to fetch the models. One of the space is that GitHub. So let's go to the GitHub directly. Okay, let's go to the GitHub. Okay, go to the GitHub. I can directly go there, and let's create one separate branch. Uh, we'll create a separate repository, not a branch. Sorry, uh, repository will create it. Oh, where is that? Yeah. Um, leave it this one. I'll create a new one. It's older. Face mask. Deep learning projects. Okay, deep learning projects will go for it. So in a deep learning project, okay, your code space is ready. And let me just directly go to click on a code. Okay, and what else? So, ah, Let's upload an existing file. Here is already option is there. Let's upload some existing file. Can I just directly upload it or model? Because model should be available some cloud space. So GitHub is one of the option. Let me just try to upload it on GitHub here in GitHub. So when you just try to upload it, saying that that's a big file, and try again, file is smaller than the 25 MB, because the size of our model is that it's around 102 MB, and GitHub is providing the space, which is the very less space they are providing, which is just the 25 MB, because it's made for a code, not for uploading the data, uploading the models. So I have to choose some place where I can directly take it. And GitHub, we can easily configure it. If the GitHub is not available, then what's the next? So next is that you can just use a Hugging Face. So if your model is a little bit big nowadays, not only the deep learning model, we have a large language model is available. So large language model, of course, it's more than 100 MB. It can be the GB and a TB as well. So how can you upload it? So that's why we require a different space, which is the Hugging Face is one of the best spaces there. We can upload the model. Let me just check it. Where is that? You have to create one first account. Hugging Face. Hope is here. After creating the account, the interface will be look like in this way. Now you have to go here in this icon. Then you'll find it out the new model. When I click on a new model, and you can just write owner will automatically showing it here. You can also create a multiple owner as well, but that's not important. And you can write the model name here: face mask detection detection. Okay, and nothing you have to do it. Just directly click on create model. So go to add model card, then you'll find it out the file uploader, and here you can directly drag and drop, or you can also select it. So when I click on it, then you can directly go to the face mask detection and where exactly the model. So model is available. Is my direction, yeah, face mask model.h5. Click on it, and then it just is working like GitHub. So you can easily relate with it here, and click on commit changes, and then it will take time to upload it, because of course it will be required the yeah, it is uploaded here. It's too fast. Okay, so when you click on this model, and of course you have to connect these things with your account as well, right? You want to connect with it here. So in that situation, what you will do, just go back to the code again, and I already write the code here. Okay, I already write the code here and mark down till completed. Now we have to load the model. Okay, so loading the model, I have already write the code. So let me show you. And you have to just take it Hugging Face hub, and then yeah, this is the model things here, and whatever the repo name is there, you can directly copy it, and whatever the file name, and if you want to create the cache directory, if you want, otherwise it's not even required. So model path, you have to define it, and then it will be directly loading from there only. So let me go back and just check it, is the same model app just using it or something else. uh, so you can directly copy it here. Okay, you can directly copy it, or else yeah, you can just copy it here, recurrent face mask detection. Go back, and recurrent face mask detection, you can directly paste it. Okay, detection. Okay, and face mask model.h5, and yeah, perfect. So if you want to just check it, you can just click on control S, and go back that where exactly is loading. Okay, and source file is change return, and yeah, when you just run it, so it will take time to model. It's a completely the 100 MB, and it's taking from the Hugging Face. So of course it will take time. Let me also directly refresh it. So when you just refresh it here, then you can see it's properly running, and it take time because it's loading the model. Yes, running, loading the model. Okay. So everything is coming up, but the same time is also loading the model. If you want to change something, if you want to showing some fancy icons here, you can also do it with a copilot. Of course, you don't need to do it manually. Okay. And yeah, you can also just check it, the logs as well, how much is completed, how much is not. Okay, let them complete. Let them complete. In the same time, I'll also just add the other features as well. Now we have to upload the images, right? Model is loaded. 100 uh, 102 MB model is loaded, and the same time model cache as well from the Hugging Face, so that next time you don't need to load the model. Okay, next time you don't need to load the model because it's taking a time. Every time if you just run it, so of course it's taking a lots of time. So better you can just use it cache. Okay, so I have a uploader section. I have uploader section. Now I'll just go with the file uploader. So any JPG, PNG, any kinds of images is there that can be uploaded. And if the file upload is there, then I'll just go with same kind of operation which I just perform in Jupyter Notebook. Okay, I already have a code. So let me just directly copy paste here. Wait a second. Okay, so here your main logic is coming up. So this is the logic. Let me just close it. This not a close it. Let me scroll down. Okay, you can see what I did here. What I just performed the operation on your Jupyter Notebook. The same operation I have performed. Okay, so your images will be stored on uploaded files. So of course it will be stored on a image.open. Image.open it here, then we'll convert into the array. And after converting the array, and with we are just taking the we just showing the images as well. st.images, in the sense it is for showing on a Streamlit. Okay, and then we'll also resize it with a 128 pixels, 128 pixels. Then we perform the normalization, and then np dot expand deems. Same thing we perform it, and model we already loaded. Then we'll do the predictions, and we'll perform it here. Mask confident and no mask confident. We'll take it and the condition I have applied, and just we normally displayed it. Okay, normally we displayed it. Simply we displayed. So I think we're done. Let's save it. Um, I don't think so. It's much difficult to understand it, this entire code, because of course I didn't write it each and everything. I also take it from the Copilot because this is just a deployment, the local deployment, and after that we'll go for the cloud deployment, right? Now this one is done. Let me again back and refresh it. We'll directly refresh. We'll directly refresh, and then creating the images, browse it. So when I just browse and face mask detection, I'll go with the place where the dataset is available in a split frame. I'll just go with without mask. Okay, I'll just taking any kinds of images open. So it will taking the images, and hopefully uh, choose the model, and saying that no mask detection and 100% confident. Okay. So below you can also see that graph as well. There is no any probability to detect that more person is wearing the mask. It's very much confident for not wearing the mask. Let me also just take it the images which is wearing the mask. Go back, and if I was just taking like this, okay, some images, I'll just take it, and now it's saying that 99% is detected that no mask detection. Of course, the model is not as much strong. That's why it's predicting wrong. This is predicting wrong. And at the same time, you can also see the graph as well. So as I said, I have also check it the multiple images. So one images is properly predicting it here, like this images, and you just check it. Okay, and it's saying that yeah, 94.5% is saying that mass is detected. And the same time you can see the graph as well. 5% 5% confident is that there is no mask probability. Okay, so now we deployed it, but again this is on a local. It's time to go on directly on a live. For deployment on a Streamlit, you have to create an account on streamlit.io. Streamlit.io. Uh, when you click on it, then you have to click on a free and then create an account. Okay, for me, you can directly create an account from the GitHub. Okay, so and of course you have to create an account for a GitHub, not an optional thing. Okay, so when you create an account, you'll find it out the user interface is look like in this way. And uh, so whatever code will be uploaded on the GitHub, and everything you can just connect it here. So first thing is that you have to upload all the code on the GitHub first, and then we'll connect here. So in our section, you can see there is no any kind of requirement.txt is available. Requirement.txt will help you to just take it how many libraries are you are using it, because the same library you have to also install it on streamlit.io. So we don't have, so I'll create it here, the library agent mode, and please create requirement requirements.txt, uh, because for given version of for, and you can also just take it what version you are just using it. Okay, I can directly close it. Okay, we don't require uh, Python version for Python version, which is the 3.9.11, same for Python 3.9. So when you just click it, so agent mode is there. So directly will create the requirement.txt. In case if you don't have the Copilot with agent mode, you can directly do the copy paste from there, right? Uh, so here it's creating, and again I request you, if you're not able to connect VS Code with the Copilot, so watch this video. I have explained each and every steps. uh, yeah. So you can see all the required libraries has created. Just have to click on keep anywhere. Keep here, here, anywhere. You can just do it. So now requirement.txt is also available, and let's upload it each and every files. Where is that? Yes. I require two things. I required app. I required requirement.txt. Okay. Because model anyhow is coming from the Hugging Face. Okay. And we'll commit it. You have a two option. Either you can just connect a terminal with a GitHub and then do it, or you can directly upload it here. I'm not going to explain you how to connect with a GitHub with any terminal. If you need, you can also refer it some videos and do it. But anyhow, your code should be available at here. App.py requirement.txt. That is enough to here. Okay. Now go back to streamlit.io, create app and deployment with the GitHub, and a repo you have to define it. So what is the repo name? You have to just check it, deep learning project. So requirement deep learning project or projects. Uh, deep learning projects. Deep learning projects. And it's the main branch. And what is the main file name? That is the app.py, not Streamlit app. It's app.py. Okay. And if you want to give the some specific name is here, I want to give the recurrent AI. Yeah, recurrent AI face mask. Recurrent AI face mask. Okay. So of course, domain is available, and we can directly deploy it, but just go to the advanced setting and check it which Python version they are using it, 3.14. I have to choose it 3.11 only, because we also use the same 3.11 only there. So click save and now deploy. So entire deployment phase, you can also just check it. I'll show you where you can find it out. When this deployment will start, okay, now deployment is started here. You can just see the manage.app, scanning, spinning up manager process, each and every steps you can just see it. So deploy all the deployment process, you can also see it here. It will take time to give the complete deployment. In case if you're getting the error, we'll also solve it. Okay, now deployment is completed. I can just go back and click on a file. I'll follow the same thing, dataset, split, and training. With mask, I'll also take the same images. Let's see what is giving the answer here. Original image, yes, same answer is giving. And this is the URL. Uh, the URL, if you share with anyone, they can directly access it in this project, and they can upload the images and just check it the person is wearing the mask or not. Or else you can also just do the inferencing here. There are lots of things you can do it, but yes, deployment is properly completed. Find this video is helpful for you, please like this video and share with your tech friend, those who are working or learning the data science. Until then, you can just enjoy this project. Subscribe this channel to get the more informative video on data science.